Gravitational potential. Gravitational potential is a scalar quantity. Whenever there is field at some point, it is likely to have some finite value. Gravitational potential is considered zero at infinity. That means we define potential at any point in terms of infinity only. It is equal to work done in bringing unit mass from infinity to a point. That means as a mathematical formula, we can use this work per unit mass. Gravitational potential will always be negative. Why? Because the work is automatically obtained by the gravitational force. We need not do the work in this process. Suppose a mass capital M and at a distance r you consider a point P where test mass small m is supposed to be placed, then at this very point the potential will be minus gm upon r. You know, we can use the force acting on this small m. We can consider a small distance. Work can be calculated, then by taking the limit from infinity to this particular distance, we'll ultimately find this result. This is negative. That clearly indicates that gravitational force is attractive one. Now, in order to find the values of potential by the sphere, we'll again have like this field, will again have this thing in mind that outside the sphere, both solid and hollow behave in the same manner. For outside the sphere, the potential will be given at a distance small r from the center of the sphere. And that on the surface, it will be equal to this thing. Capital R is the radius of the sphere and small r is the distance a point outside the sphere from the center of the sphere concerned. Now let's consider the points inside the sphere. For that, we'll consider the solid sphere first of all. Inside the solid sphere, if you consider some point, see like this here, this point at a distance is small r from the center, potential would be given by this ratio. Then if you put r equal to 0, that means center, you'll find this value at the center, whereas on the surface, you know this. So ultimately, if you compare the two, you'll find potential at O is equal to 3 by 2 times the potential on the surface. This is for solid sphere, and this is exactly applicable that for Earth also, which is a matter of concern for us. Now we'll consider the hollow sphere. Hollow sphere, keeping in mind that outside both the spheres behave in the same manner, inside their behavior is different. See, it is hollow sphere, and we'll consider the points outside and inside both. The points inside will have the potential same as that on the surface. Same potential. On the surface, you know, here it is minus gm upon r. R is radius of the sphere. Whereas inside you consider any point, even at center, all the points. This is very simple thing to be remembered, that hollow spheres will have the same potential throughout inside as that on the surface. So the value on the surface is this. Suppose it is VP and this is point O, center, VO, both will be equal. This is also equal to minus gm upon r. That's why the graph is here depicted, and both are having this point on the surface, this point at the center. both are same, inside throughout the value is same, and after that again this relation will continue. Vp for outside points, this is minus Gm upon small r. This is proportional to 1 by r. Here we have chosen x and this side is potential.